Today, the internal combustion engine is used in motorcycles, automobiles, boats, trucks, aircraft, ships, heavy-duty machinery and power generators. A four-stroke engine is an internal combustion engine in which the piston completes four separate strokes: intake, compression, power, and exhaust during two separate revolutions of the engine's crankshaft, and one single thermodynamic cycle. Let's take a look at the basic internal parts of a four-stroke engine. Inside the engine block, there is a crankshaft. Piston rods are attached to crankshaft. Pistons are attached to the piston's rods. As the crankshaft turns, it causes the lifter to make each piston move up and down. At the top of the crankshaft there is a camshaft which is connected to the crankshaft by a timing belt. While the crankshaft is making the pistons move up and down, the camshaft is turning, making the valves to open and close. Let's now take a look at how the combustion creates piston's motion. First, intake stroke. The inlet valve is opened, and the fuel-air mixture is drawn in, as the piston travels down. Second, compression stroke. The inlet valve is closed, and the piston travels back up the cylinder, compressing the fuel-air mixture. Just before piston reaches the top of its compression stroke, a spark plug emits a spark, to combust the fuel-air mixture. Third, combustion stroke. The piston is now forced down by the pressure wave of the combustion, of the fuel-air mixture. The engine's power is derived from this cycle. Fourth, exhaust stroke. The exhaust valve is opened, and the piston travels back up, expelling the exhaust gases through the exhaust valve. At the top of the stroke the exhaust valve is closed. This process is repeated. What had been presented is the cycle of operation of one cylinder, of a four-stroke engine. Generally engines have two or more cylinders acting in concert with each other to produce the engine power.
The modern common rail system sends 1,800 bar of injection pressure to the fuel injector needles with piezo injectors, which distribute the power optimally in the combustion chamber. Due to the extremely quick reaction time in millisecond range, up to 5 separate injection processes can be achieved per cycle, which are also variable. In addition to the main injection processes, pre- and post-injection processes are also possible. Pre-injection moderates the acoustic hardness, the so-called rattling of the combustion process. Post-injection is specifically to raise the temperature of the exhaust gas and therefore for regeneration of the standard diesel particulate filter. These factors together allow exact, highly efficient combustion. The TDI turbochargers are part of a new generation. In the intake manifold of the engine, there are swirl flaps which are used to regulate the inflow of air in order to achieve optimal combustion. This use of technology allows high maximum torque of 5,400 rpm and clearly improves the thermodynamics in the combustion chambers. It allows the engine to run with a very high rate of back-fed and heavily cooled exhaust gas.
Let's look at the two-stroke diesel engine cycle. Once again, the 5 key events occur, but in a different way. At the start of air intake, the piston is moving towards bottom dead centre at the end of a power impulse. The piston uncovers the inlet ports and the blower delivers fresh air into the cylinder. The exhaust valve opens. The piston reaches bottom dead centre and starts its move upwards. Incoming air scavenges exhaust gases out of the cylinder. The piston continues up, covers the air inlet ports and cuts off the air supply from the blower. The exhaust valve closes. The piston approaches top dead centre, compressing the air and raising its temperature. Just before the piston reaches top dead centre, the injector sprays in fuel. The heat of the compressed air ignites the fuel. Pressure from the expanding gases forces the piston down the cylinder in a power impulse. Before the piston reaches bottom dead centre, the exhaust valve opens and burned gases escape. The inlet port is uncovered and it admits fresh air from the blower. The piston reaches bottom dead centre. The cycle is ready to repeat itself. All 5 events occur in just 2 strokes. How many revolutions does the crankshaft do in one engine cycle? 1 revolution per cycle.
These function the same as those in a 4-stroke piston engine. To name the 4 strokes, first, the intake stroke, where the intake air is allowed into the combustion chamber through the intake port. Secondly, the compression stroke, where the intake air is compressed by the changing volume of the chamber. Then, as the chamber passes the dead center point, the chamber is split into 2. In the case of the COFA multi-fuel motor, the rotor has an exclusion, which allows the air to pass through and fill the next chamber. While this air is streaming through the exclusion at high speed, the fuel is injected into the high-speed stream, allowing a good mixing of fuel and air. The fuel is then ignited. During normal operation, the ignition occurs due to the high temperature and pressure caused by the extreme compression of the intake air. To help under starting conditions, when the motor is cold, a spark plug can aid the ignition process. Then comes the 3rd stroke, the expansion stroke. Here, the ignited mixture exerts pressure on all sides of the combustion chamber. The side created by the rotor is hereby forced to move to allow the mixture to expand, forcing the eccentric shaft to rotate. This rotation of the shaft is then the driving power of the motor. Then comes the 4th stroke, the exhaust stroke. As the tip of the rotor passes the exhaust port, it opens the combustion chamber, allowing the exhaust gases to escape. The combustion chamber is reduced in size due to the shape of the housing and the movement of the rotor. This forces the exhaust gases to be expelled. The special shape of the rotor and housing creates 3 combustion chambers. This means that a single rotor Wankel engine is comparable to a 3-cylinder piston engine. The modular design of the COFA multi-fuel Wankel motor allows the simple extension of the motor to create a 2-rotor motor, using exactly the same end housing together with an identical combustion chamber housing and a connecting housing. Here we have quite simply created a 4-rotor engine. With 3 combustion chambers per rotor, this is equivalent to a 12-cylinder piston engine.